Hello everyone, this is Raman Rana here, mathematics teacher, Cambridge International School, Dasua. Today we will discuss the criteria for similarity. I hope you have gone through exercise 6.2. Let's quickly go through those homework questions. Question number 5, diagram is given. In question number 5, we have given one triangle PQR, triangle PQR in such a way that here we have a point E, one point O here, this point is R. P, Q, R are the vertices of triangle. O is the point in between the triangle, such that here what is given, that DE is a point here, F is a point on this side, and there is a point D here, such that ED, it is given, this is a point D here, given that ED, this point is D here, ED is parallel to OQ, and DF or FD is parallel to OR. Now join E with F. To prove, we have to prove that EF is parallel to QR. So it's a simple application of the basic proportionality theorem. So here we will apply BPT in a triangle PQO first, where ED is given parallel to OQ, and then in triangle POR, and from these 1 and 2 equations we can, with the help of BPT, we can come to this result. So in triangle, how to start? In triangle PQO, here it is given ED is parallel to QO. So BPT says, by BPT, basic proportionality theorem says that your PE upon EQ is always equal to PD upon DO. Take, this is question number 1. Similarly, in question number POR, DF is parallel to OR. In triangle POR, here DF is parallel to OR. So by BPT, we can write that this PF upon FR is equal to PD upon DO. So it is evident from both the equations, from equation 1 and 2. From equation 1 and 2, we have right hand sides are equal. This implies that your PE upon EQ, PE upon EQ is equal to PF upon FR. So in triangle PQR, if we have PE upon EQ is equal to PF upon FR, so by converse of BPT, we have EF is parallel to QR. So I hope the question is very clear to everyone. So next question is question number 6. Again, diagram is given. In question number 6, again we have a diagram in this way, where PQR is a triangle and again O is the point, in such a way that O is a point here, given that AB, in this question what is given, AB, A is a point here and join A with B, B is a point here, AB is parallel to PQ given, and here is a point C such that AC and AC is parallel to PR. To prove, in this question we have to prove that BC, the third side BC, is parallel to QR. So here we can again apply the concept of BPT. Here AB is parallel to PQ and AC is parallel to PR. So we want to prove BC is parallel to QR. So in triangle here, OPQ and triangle OPR, we will apply the concept of BPT, that PA upon AO in triangle, your POQ, AB is parallel to PQ. So by BPT we can write that OA upon AP is equal to OB upon OQ, and we'll take this as equation number 1. This is equation number 1 here. Similarly in triangle POR, AC is parallel to PR. So we can write again OA by BPT, the side OA upon AP is equal to OC upon CR. This is equation number 2 we can take. Now from 1 and 2, left hand sides are same, so right hand sides must be equal. So from equation 1 and 2, we have OB upon OQ is equal to OC upon CR. So in triangle PQR, if we have OB upon BQ, OB upon OQ, sorry, it is BQ here, BQ, because it is OA upon AP, it is equal to OB upon BQ. So here it is BQ is equal to OC upon CR. So by converse of BPT, basic proportionality theorem says that these lines BC, side BC is parallel to QR. So this is question number 6. Both the questions number 5 and 6 are very easy questions and mostly asked in the exams. We have some criteria for the similarity. First one is A rule, angle rule of similarity, and it is also known as AA rule. So here theorem 6.3 contains the AAA criteria for similarity. the theorem 6.3 says that if the corresponding angles in two triangles are equal, then the ratio of their corresponding side is always same. So how to prove? Here we can draw two triangles, one triangle ABC, ABC, and another triangle DEF. So what is given? Angle. Angle A is given to D. Angle A is equal to angle D. Angle B is equal to angle E, given here that, and angle C is equal to the third angle is given. So it is given here F. And to prove that the ratio of AB upon DE is equal to BC upon EF is equal to AC upon DF. So according to the theorem 6.3, if the angle, three angles of a triangle are equal to the three angles of another triangle, then the ratio of their corresponding side is always same. So here we will put point P here such that cut DE in such a way that DP is equal to AB and AC at a point Q here. This AC is equal to DQ. Join P with Q. Now here in triangle ABC and triangle DPQ, AB is equal to DP, angle A is equal to angle D, and AC is equal to DQ. So these two triangles, triangle ABC is congruent to triangle DPQ. So here, what is the criteria for congruency? Here, side, angle, side. So by side, angle, side rule of congruency. Now, if these two triangles are congruent, by CPCT we have angle, by CPCT we have angle B is equal to angle P and angle Q is equal to angle F. So if these angles are equal, means these are corresponding angles, so this implies that your PQ is parallel to EF, and if PQ is parallel to EF, then by BPT we have DP upon PE is equal to DQ upon QF. Also, we have gone through the concept of BPT in detail. We can write DP upon DE. DP upon, by taking reciprocal and adding 1 both side, we can write also DP upon DE is equal to DQ upon DF. So here in place of DP we can put AB, and in place of DQ we can put AC. So here this implies that your AB upon DE is equal to AC upon DF. So similarly, Similarly, we can prove for the third side, that is your BC upon EF. So here, this is the proof for the very first rule, AAA rule, angle criteria for similarity. So here we have gone through the two triangles by constructions. We have take one point P, which is such a way that DP is equal to AB and DQ is equal to AC. By side rule, these two triangles ABC and DPQ are congruent. Once two triangles are congruent, by CPCT we have angle B is equal to P and C is equal to angle Q. So now in this triangle DEF, these two angles are equal, means these two angles are corresponding angles, so PQ is parallel to EF. And then we have applied BPT here and its properties, and we have proved the rule, AA rule. Now we know that if in a triangle, in two triangles, only two angles are given, then AA is also a rule, because angle sum property of a triangle says that if two angles are equal, then third angle must be equal by angle sum property of triangle. So AA rule and AA rule are one and same. Question number 7 and question number 8 specifically given that use property or theorem 6.1 and 6.2. Question number 7. Question number 7. If in any triangle ABC is a triangle, question statement say by using theorem 6.1, that is BPT, if any line drawn parallel to any one side, and that is from the midpoint of any one side, if here E is the midpoint, and if any line is drawn parallel to the third side, let this side is BC and let the line is EF. So here given that E is the midpoint, E is the midpoint here, means AE is equal to BE given, and a line EF which is parallel to BC. E is the midpoint of the line segment, the side AB, and here given that EF is parallel to, EF is drawn in such a way that EF is parallel to BC. So I am again repeating the statement of the question, that prove that a line drawn through the midpoint of any one side and parallel to the third side always bisects the other sides. Means we have to prove here that F is also the midpoint of AC. So to prove here that F is the midpoint of, F is also a midpoint of AC. So using theorem 6.1, that is BPT here, we know BPT says in ABC triangle EF is parallel. So by BPT, basic proportionality theorem says that AE upon EB is always equal to AF upon FC. Simple statement of BPT. But we know E is the midpoint, so AE upon EB is equal to 1, because AE is equal to EB. So here from 1 from 1 because AE upon EB is equal to 1. So AF upon FC is equal to 1. This implies that AF is equal to FC. So this further says that F is a midpoint of AC. Similarly, we have the question number 8. Here it is given in the book that by using theorem 6.2. So 6.2 theorem is the converse of BPT. So statement of 8th question is that ABC is a triangle. The statement is that prove that the line joining the midpoints of any two sides. Take P and Q are here the midpoints of the two sides. The line joining the midpoints of the any two sides is always parallel to the third side. So here given that P, or you can write AP is equal to PB, and here this side is equal to this one, and AQ is equal to QC. Join P with Q, or Q is the midpoint, AQ is equal to QC. To prove, what we want to prove here, we want to prove that PQ is parallel to BC. So here we know PA upon PB is equal to PA in triangle ABC. AP upon PB is equal to 1 because, and this is further equal to AQ upon QC. Okay, so here if AP upon PB is equal to AQ upon QC, so by converse of basic proportionality theorem, we have PQ is parallel to BC. So here in both the question 7 and 8 we have solved in grade 9. The topic was the midpoint theorem, but here we are solving these both questions with the help of basic proportionality theorem, 7th with the basic proportionality theorem, and question number 8 with the converse, that is theorem 6.2. So the last question is question number 10, exercise 6.2. Question number 10 says that if in ABCD is a quadrilateral in such a way that AO upon BO is equal to CO upon DO. It is given here, if a quadrilateral AB, C, D is given, D is a point here, and the diagonals of the quadrilateral at O. So AO upon BO is equal to CO upon DO. It is given. Here ABCD is a quadrilateral, and to prove we have already solved question number 9. So here to prove that ABCD is a trapezium, means we want to prove that AB is parallel to the side DC. So here if we are going for the triangles, then it is AO and OC side. The diagonal AC is OA and OC. So we can rearrange. We can write here that AO upon CO can be written as your BO upon DO. Just rearranging. So this statement is already given here. Now by construction we can solve it in another way also, but here with the help of construction we will take any point by construction E here such that this is OE. Let E is a point. Take by construction E is a point on AD such that EO is parallel to DC. Now if EO is parallel to DC, so by BPT we have AE upon ED is always equal to AO upon OC. That this is equation number 1. Now in triangle ADB, in triangle triangle A, because here we have already given that this is equation number 1 and this is equation number 2. From 1 and 2 these sides are equal, so this implies that this implies that BO, your AE upon ED is equal to BO AE upon ED is equal to BO upon OD. BO upon OD. Now in this triangle ABD, what we have, by converse of basic proportionality theorem, by converse of basic proportionality theorem, we have here that EO is parallel to AB. So we have two things. By construction we have taken that EO is parallel to DC, right? And by applying the basic proportionality theorem, EO is also parallel to AB by converse. So from these two equations we say that AB EO is also parallel to your DC. So from these we can write down AB is parallel to DC. Now if AB is parallel to DC, therefore ABCD is a trapezium. So this is all about the exercise 6.2. Another rule for the similarity is side, side, side. Side, side, side rule of for similarity means if the ratio of the corresponding sides of two triangles is same, then the two triangles are similar. To understand this rule, let's go for one activity. Draw two triangles. One triangle ABC, A, B, C. This is 3 centimeter, this is 6 centimeter, and this is 8 centimeter. And draw another triangle which is here 4.5 centimeter, 9 centimeter, and 12 centimeter. D, E, F. By construction, draw two triangle. So here AB upon DE is equal to BC upon EF is equal to AC upon DF is equal to 2/3. These two triangles, and we are doing activity here. We are doing activity. Means you have to construct two triangles in such a way that the ratio AB upon DE is 2 by 3, BC upon EF, BC upon EF is again 2 by 3, and the same for the third side AC and DF. Now do one thing, measure all the 6 angles. After measuring, if your construction is right, after measuring the angles, you will find that angle A is equal to angle D, angle B is equal to angle E, and angle C is equal to angle F. You can do this activity or this work so many times with the ratio, corresponding ratios of the two triangles same. Then we will find always that the corresponding angles are of same measure. So this is the proof. If only the ratio of the two the triangle, two triangles, that is side, side, side is given, side means ratio of the corresponding side, then the two triangles are said to be similar. So here in its proof also we will move ahead in the same way. We will take a triangle ABC, ABC, and we'll draw one more triangle, that is DEF, and with the help of construction we will cut here DP and DQ such a way. Now in these two triangles the ratio of the corresponding side is given. So here we are taking AB is equal to DP and this AC is equal to DQ. So here we can write that in place of AB we can put DP upon DE is equal to your DQ upon DF is equal to the third side, that is PQ upon EF. So here we have these two triangles here ABC and DPQ, they are congruent because here we have BC is equal to PQ and triangle ABC is congruent to triangle DPQ. So once these two triangles are congruent, why these are congruent? By side rule of congruence, and by CPCT we have angle A is equal to angle D and angle B is equal to angle P and angle C is equal to angle Q. So this is the second criteria, that is side criteria for the similarity of two triangles. The last criteria for similarity is side angle side. Side angle side. Theorem 6.5 specifically talks about this side angle side rule. So we can do one activity also. We can take two triangles in which the sides containing these angles, these two sides are proportionals and the angle between them is same. So we will find that this type of two triangles are always similar. So again here, to prove the side angle side rule, we will go for two triangles. Like one is triangle ABC, ABC, and one triangle is DEF, DE and F here. Now if it is given here, given that AB upon DE is equal to AC upon DF, and the angle between these sides AB upon DE and AC upon DF, the angle between these two sides is equal. That angle A is equal to angle D. So theorem 6.5 states that in a two triangle, the ratio of the two corresponding sides is same and the angle containing these two sides is also equal, then two triangles are always similar. So its proof, again by construction, we will cut this DE at a point P and at point Q such that here AB is equal to DP and AC is equal to DQ. Now we have AP is equal to DP, so we can write DP upon DE is equal to your DQ upon DF. So by converse, here DP upon DE and DQ upon DF. By converse of BPT, by converse of BPT, we have PQ. PQ is parallel to EF. Now, if PQ is parallel to EF, then angle P is equal to E, angle P is equal to angle E, and angle Q is equal to angle F. So here we have triangle ABC is again congruent to triangle DPQ by side rule of congruence. So here we can prove that if side that AB upon DE is equal to AC upon DF, then we have by CPCT angle A is equal to angle, these angles are further equal, and angle A is equal to D, it is already given, angle B is equal to angle E, and angle C is equal to angle F. So here we can say these two triangles are similar. So let's go for a few examples. Example number 4. Example number 4 says that if PQ is parallel to, if given PQ is parallel to RS, PQ and RS, where these intersect, this is a point O here. So given here, if PQ is parallel to RS, then prove that triangle POQ is similar to triangle SOR. So here these sides PQ is parallel to SR given. So here in triangle, angle P is equal to angle S. Angle P is always equal to angle S, and angle Q is equal to angle R, because these two lines are given parallel. So here we will give the reason, these angles are alternate angles, and already third angle, that angle POQ and SOR, they are vertically opposite angle. So angle POQ is equal to angle SOR, vertically opposite angle. Therefore triangle POQ is similar to triangle SOR by a rule of similarity. So here we have one more example, example number 5. Here we have to observe two triangles. Here triangle one is ABC, one triangle is ABC, and another triangle is DE, or here in the question it is given P, here it is PQR, and the sides are given here. This side is 3.8 and this side is your 3 and root 3, and angles are also given, two angles, one angle is of 80 degree and this is 60 degree, and the third side is 6, and in this triangles no angle is given but the sides are given. This is 7.6, this side is 12, and this side is 6 and root 3. So here we have to find angle P. So example number 5, this is 1 mark question. So the one who is having the knowledge of similarity can answer it rightly. So dear students, all the sides of both triangles are given. AB is given, BC, AC, and here PQR triangle, all three sides are given. So by angle sum property we can find the third angle here. This is 40 degree because 140 plus 40 is 180. So here we have the relation 6 into 2 is 12, 3.8 double is 7.6, and 3 under root 3 double is 6 under root 3, or we can write here that 3.8 upon 7.6, that is your AB upon R cube, that is equal to 1 by 2. So here is equal to 6 by 12, again it is equal to BC upon PQ, and the third side, that is your AC with PR. So here we will check 1-to-1 correspondence. So here angle R, and it is 80 degree, and angle here, this angle is here of 60 degree, and the required angle which we are asking is here, because triangle ABC is similar to triangle R, because angle A and R are same, and QP. So angle P and C, they are, angle P is equal to 40 degree. So the sides, see, one side its double is here and 6 double is 12. This is the angle between these two sides. So this is a 1 mark question here. So we have one more example, example number 6. Example 6 says that if a figure is given in such a way, this point is O where the two lines intersects, and one point is AD, this point is AD here, and this side is your BC here, and given here we have OA, OB into OB is equal to OC into OD. So here we want to prove that angle A is equal to prove angle A is equal to angle C, and angle D is equal to angle B. Angle A we want to prove C and angle D is equal to B. So here in these two triangle, first we will prove the similarity here. So here from the given statement OA upon OC is equal to OD upon OB. Just cross multiplying we get this equation 1. And in these two sides OA and OD, OC and OB, the angle between them, the angle AOD is equal to angle COB. Vertically opposite angles. So here triangle here AOD is similar to triangle COB by side angle side rule. And by similarity criteria we have angle A is equal to angle C and angle D is equal to angle B. So dear students, with this you can go ahead for exercise 6.3. Stay safe, stay healthy. Thank you very much.